Okay, let's read through. It says, A is A years old, B is B years old. After how many years will A be n times as old as B? Well, I'm going to say X is the number of years. This is the how many years. I don't know. So I'll say, how old will A be in X years? A will be A plus X. Whoops. A plus X. And how old will B be in X years? It will be B plus X. But now they're saying that, then A is going to be n times as old as B. I'll write that down for you. Now, of course, the next step is to, get the how many years, because that's what they want to know. So I have an equation to solve. So you get A plus X. I'm going to say Bn plus Nx. Well, I'm going to say Nx minus X and A minus Bn. Well, let's keep moving. I'm going to factor out an X. You get N minus 1 equals A minus Bn. And I'm going to divide both sides by the coefficient on X. And I get this over here. So X is going to be equal to, relatively simple by the way, A minus Bn. And what do you get on bottom? You would get N minus 1. All right? So I want to point out in a key, you're seeing that right over here. Again, with the understanding that X represents the number of years to meet the stated condition. So we're getting what they said. And they said, discuss the case, a solution in a case when N equals 1 and A is not equal to B. Well, if A is not equal to B and N is equal to 1, it's definitely undefined. All right? So now why is that? I would have no cancellation of the N minus 1 business. Okay, so let's do the next one, right? So N can't be 1 in the case where A is not equal to B. And then the case where N equals 1 and A equals B. Well, let's write that down. Whoops. That's going to be interesting, isn't it? Well, if A equals B, you can get A minus A equals B, right? And what do you get on bottom? N minus 1. A kind of interesting problem over here. So let's write this down. X equals, I'm going to pull out actually a minus A on it. And we'll give here N minus 1 over N minus 1. All right? And, the bottom line is you're looking at a little kind of strange over there. So I want to go back to the original statement and do that instead. All right? So let me erase this over here. And let me erase this over here. And let me go back to the original statement without any kind of divisions in it. All right, so let's write this down. So the first case says, this is when N equals 1 and A and B are not equal. So I'm going to say it's impossible, just by looking at the original statement, this statement over here. Let me tell you why it's impossible. So A plus X equals, if N is 1, this would be B plus X. All right, I hope you realize X disappears. What does it say? A would equal B. Again, we're looking at the original statement they said, this one over here. All right, so I'm going to say, discuss the solution in the case when N equals 1 and A is not equal to B. It's impossible. It's not possible. Because if A is not equal to B, I don't get that. The next one they said, when N equals 1, well, I just did that, and A equals B. Completely possible. All right, right over here. This completely makes sense, by the way. All right, A and B are equal then. All right, that's about it. So it's kind of a problem that makes you think about what the problem is. But I want to, again, when you solve this thing over here, it can be a little bit confusing. That's what X is, by the way. But that's why I went back to the original to understand what they were asking me to do. Look at the original statement. Don't look at a solve for X or anything. I'm just too confusing. Thank you.